Good afternoon, students. I'll continue from where I left in the last class, right? So, second class of units and measurement, right? Okay. In the last class, we have discussed about some system of units, CGS system of unit, FPS system of unit, and then EMKS system of units. But now we are heading towards very important and now worldwide accepted system of unit is SI system, right? Okay, from this class I'll start with SI system of units, right? Okay. Let's go now. SI system of units. SI system of units, right? Okay. Actually, this SI abbreviation has come from French language. Actually, SI stands for System Internationally unites. With this, SI, the name has come from this. System Internationally D-Units. So this is SI, the name has come, right? This is the France language. Okay, now all the intelligent minds, they have decided, okay, for transaction of goods from one country to another country, like making conversion of like mass to conversion of mass from one country to another country, like business problem, like transportation. In many cases, so one country is using one system and another country is using another system. So during that international transactions, international exchange of goods and all at that time, so different countries is since using their different system of units, it was difficult. Now all the scientists have sat one side and they have decided the one system must every country should use. That is SI system. Now presently every country, almost every country, they are using only one system, that is SI system. It is universally accepted. Okay, this system has put forward in 1960, in 1960 here, when they go for one conference, and the name of conference, general conference on weight and measures, on weights and measures. Through this conference, they have given a birth to SI system in the year 1960, right? Okay. So now we'll see, as in this system, SI system, 7 fundamental quantities are considered. 7 fundamental quantities are considered. So what are those 7 fundamental quantities has been made in SI? Let us see one by one. So fundamental quantities made, considered in SI system. The one is, it is again all the 3 earlier fundamental has been carried forward. Length is a one fundamental unit, one fundamental quantity, and its unit is taken as meter in the SI system. So it is written with small m like that. The second one is time. Its unit that this is what second, unit is second, and this is s. In the same way, kilogram, then this is its symbol is kg. Now fourth one, electric current. Electric current, its unit is ampere. Its unit is ampere. Its symbol is E. Likewise, so again we have fifth one, amount of matter. Amount of matter. The unit of this is mole. Okay, this has been taken as a mole. In the same way, luminous intensity. Luminous intensity. Luminous intensity, the unit of that is candela. CD, like that. In the same way, last we have even temperature also. Temperature, right? Its unit is Kelvin. Okay. So in SI system, these quantities as considered as a fundamental, and these quantities cover all the branches of physics, right? All the branch. Whatever derived physical quantity you find it in physics, they are derived from these fundamental quantities, right? These are fundamental, right? The unit of those fundamental quantity, length unit is meter, time unit is second, mass unit is kilogram, electric current is ampere, amount of matter is mole, luminous intensity is candela, and temperature is Kelvin. These are all the units are decided. And these physical quantity as considered fundamental, they cover up all the derived quantities we find it in the physics, in different branches of physics, right? Okay. In addition to this fundamental, scientists have felt somewhere in different branches of physics, somewhere angle is required. Let me tell you. See here. Somewhere angle is required. The scientists have felt, for example, in a circular motion, there are many in physics, many physical quantity comes, like you may learn later. As of now, you might not have learned it. You not learned that omega is what? Angular velocity. You learn it later. Angular velocity, we define it like that: angular displacement by time taken. In physics, remember this angular velocity, don't bother about it. For this we have later chapter. And one more thing I would like to clear here itself, in this units and measurement, okay, just we are in the perspective of measurement. We are not going like every physics involved in every physical quantity. We are not going the complete concept or physics present in whatever, like electric current I written here, like candle I written. The physics involved in that in electric current I'm not taking until I complete the chapter units and measurement. In this chapter, I'm using different physical quantity. As I told you, like electric current I'm using here angular, just to take them just for measurement point of view. Like what is angular velocity, don't bother. For that we have a later chapter, right? So here only we are sticking to the measurement point of view in this chapter, units and measurement. Okay, physics of those physical quantity we learn later. So here angular velocity is also on physical quantity, you will find it later. So there, to complete the definition of this angular velocity, we required angle. What is angle here? So if any quantity goes from point A to point B. Its radius vector will sweep out some angle theta. So this angle is required for completing angular velocity. Angular velocity. This angle is required. And sometime even like looking at some requirements, like angle is required for defining angular velocity, right? Later you will learn regarding. So to fulfill all the requirements, to fulfill all the requirements, SI has planned for two supplementary angles. So two supplementary units to cover up all this, even angle point of view also, right or not? So that's the reason. Okay, like sometime, many time, you will find it in physics. So sometime what will happen? Suppose it's the other. Let me tell you. Suppose this is a candle. It is a candle. Candle. So light will from the candle will go in all three-dimensional direction. Light will go in all three-dimensional direction from the candle. In physics, we require the amount of light passed through particular cubic angle, solid angle. In all three-dimensional manner, light will go. So in physics, we want what is the amount of energy in the form of light has gone through some solid cone angle. We want some solid cone angle through which what is the amount of light energy gone. We require in physics. So to fulfill requirements of angle, the SI has given even two supplementary units. Two supplementary units for all these requirements, right? Those two supplementary units are in SI, supplementary units of SI. Supplementary units of SI. Two supplementary units are also given. One of them is plane angle. One of them is plane angle. Its unit is radian. The other one is solid angle. Solid angle. Its unit is steradian. This radian is represented with RAD like that. This steradian we represent with SR. Two angles. These two physical quantities, again, these two supplementary units also introduced in the SI system. Right? Now we'll briefly know plane angle and then solid angle. Right? See here. Plane angle. So let me take here plane angle, right? First, let me take here plane angle. Plane angle. That is, its unit is radian. Plane angle. See here, plane angle is, this is the angle subtended by a particular arc length. This is arc. AB is the arc length. The angle subtended by that arc length at the center is theta. At the center. So the angle subtended by this arc length AB at the center, how do you relate between radius in mathematics you have learnt? Radius of the circle, arc length of the circle and theta. How do you relate it? We relate like that. Theta is equal to arc length divided by radius. Like that. So here arc length I have taken here L. So it will be written L by R. Like that we write. Then what is plane angle here? Plane angle in simple, it is the angle subtended at the center by the arc. By the arc. That's what you call plane angle. What is plane angle? It is the angle subtended at the center of the circle by an arc of the circle. That's we call it is plane angle. So here Okay. So what is plane angle? it is it is it is angle subtended by the arc of circle at the center of the circle. It is the angle subtended by the arc of circle at the center of the circle. Okay, so what is total angle subtended at the center? May I know what is the total angle subtended at the center? Total angle at the center. Total angle subtended at the center, if you want, I'll write here total angle subtended will be arc length. Total angle you want means total length. What is total length? It will be 2 pi r divided by radius of the circle. Radius of the circle. What you will get here? 2 pi radian. It means total planar angle subtended at the center of the circle will be 2 pi radian. Right? Okay. Then how do you define 1 radian? How do you define 1 radian? 1 radian, what is the angle subtended at the center is 1 radian. So 1 radian you want means, see here, if suppose this is, let me take this is B. If suppose angle subtended, if you want, this angle is said to be 1 radian. If, so the arc, whatever is there, if that arc length, if it is equal to radius of the circle, arc length, if it is equal to radius of the circle, then whatever angle subtended at the center is there, that angle will be 1 radian. For example, if radius is 1 meter, if suppose if you take a arc of length 1 meter, whatever angle it will subtend here, that angle we say 1 radian. So if you take here the another is, suppose theta is said to be, when you say 1 radian, arc length is what? If I take equal to r divided by r, what you will get here? R gets cancels. What you will get here? 1. So it will be what? 1 radian. So 1 radian, when do you say planar angle subtended at the center is said to be 1 radian if the arc length is equal to radius. The angle subtended at center is said to be 1 radian if the arc length which is subtending that angle, if that arc length equal to radius, then whatever angle subtended at the center by that arc length will be 1 radian. It means if arc length is equal to radius, then angle subtended by that arc length will be what? 1 radian. Right? Okay, SI unit of planar angle is radian, not degree. Not degree. Okay, degree is also an planar angle. Other practical unit we consider it is, but SI, what is a in SI, what is a planar angle unit is radian. Radian, right? Radian. Okay, okay. This is what total angle subtended at the center of the circle. Total planar angle at the center is 2 pi radian, and then so when do 1 radian will subtend at the center? If arc length is equal to radius, right? This is what regarding planar angle, right? Okay, now, so now we'll go for this solid angle, right? We'll go now to the solid angle. Okay. Next one is solid angle. Solid angle. So the solid angle is so angle subtended by a sphere. Angle subtended by a sphere at the center. Sphere. Okay, let me say here, suppose if I take one particular sphere like that, angle subtended by sphere, angle subtended by area, the angle subtended by area. this particular area I had taken on this sphere. This is a sphere here. This is what? A sphere. So angle subtended by the sphere, let me take particular area of the sphere at the center. This angle we call it is omega. This is a solid angle, right? So this solid angle, this solid angle is a three-dimensional angle. It is subtended at the center by a particular part of area of the sphere, right? Actually, how do you define this solid angle? Solid angle, we define area divided by square of radius, right? So we define how do you define that solid angle? Area, what is the, if any, let me take this particular part of area. This area, how much angle it is subtending here? Solid angle I am talking about, solid angle. At the center, that particular area, how much angle it is subtending, solid angle at the center, okay, that particular area, this angle we say it is a solid angle, right? Okay, see here. So what is the total angle subtended at the center of this surface, so center of this sphere? Total solid angle at the center of this sphere. What is total angle possible? Total solid angle subtended at the center, can you think of, this is a formula for solid angle? Okay, solid angle, what is total angle can subtend at the center of the sphere? Area, what is the total area of the sphere? What is total area of the sphere? It will be 4 pi r square divided by r square. What you are getting here? 4 pi. Then what is the unit of this solid angle? It is steradian. What is SR here? Steradian. Solid angle unit is steradian. The unit of solid angle is steradian. What is the total angle subtended at the center of the sphere? What is the total angle at the center of the sphere is 4 pi steradian. Right? Okay. Then when do you say the solid angle is 1 steradian? When do you say solid angle is 1 steradian? So 1 steradian, how do you define it? 1 steradian. How do you define it? In case, suppose area is, suppose if I take this area as 1 meter square, right? Okay, and the radius of this, suppose if I take 1, then what will you get? Steradian, solid angle area divided by r square. So steradian, 1 steradian you will get, solid angle you will get as a 1 steradian if the area is 1 meter square divided by if the radius is 1 square. Then what you are getting here? 1 steradian. It means, its simple meaning is, if I am taking a square area on this sphere, like this is length you take, it is breadth you take. Like this is square area I taken on the sphere, square area. Square area I had taken on the sphere, square area. Suppose its length is equal to length and breadth. Like it is a square area taken. If its length is equals to radius, like this is length is equal to radius, then what should be its area? Length into breadth. It is a square, no? If I take the side of this square is a radius, then ultimately the area of this becomes what? It is actually 1 length into breadth, 1 into 1. This area becomes what? 1 meter square. What is meaning here? The solid angle subtended at the center is said to be 1 steradian if a surface if a surface area, let me take, if a square surface area, having its side equal to radius, square surface area having its side equal to radius, having its side, this side, if suppose equal to radius, if I take radius also 1, and its side of a square is also 1, then you will get, what you will get? So it will be, in case, okay, this is what side is 1, radius is 1, 1 into 1 is 1, radius, what do we get the formula? 1 square by 1, it will be 1. In another way also, in case suppose its side is equals to radius, its side is equals to radius, I chosen a square area on this sphere, I taken a square area on the sphere, that square area having its side is equal to radius, its side is equal to radius, then what about the area of this will become? Is equal to its side, if it is equal to radius, then it is a square area, r into r. It will become what? It will become what? R square. It will become r square. Area r into r, it will become what? R square. Right or not? Therefore, so according to the formula we have for solid angle, area becomes what? Solid angle, okay, is equal to, I told you, 1 steradian you want means choose a square area on the surface of the sphere. The side of that square area, if it is equal to radius, side of that square area, if it is equal to radius, then what is the area of that? It will become length into breadth. Then in denominator, what is there? Radius square is there. Then what you will get? Solid angle. What you will get? Solid angle is equal to 1 steradian. 1 steradian. When do you get 1 steradian? Like I told you the definition. So square area on the surface of sphere, having its side length equal to radius, then what is the area of this? It will become length into breadth of this square area, r into r square, divided by defining process of solid angle contains r square, so it gives you 1 steradian. Right? In brief, I'll tell you, 1 steradian solid angle is subtended at the center of the sphere if angle subtended by a square area, having its side equal to radius, then that angle subtended will be taken as 1 steradian. Right? So in another way also you can write it. See here, angle subtended at the center of sphere is said to be 1 steradian if surface, square surface area on the surface of sphere having its side equal to radius, then that square area subtends 1 steradian solid angle. Getting my point? What is here? Angle subtended at the center of sphere is said to be 1 steradian if a square surface area on the surface of sphere having its side equal to radius, then that square area subtends 1 steradian solid angle. Right? Okay, this is one solid angle. What is the total solid angle subtended at the center of the sphere? 4 pi steradian. 4 pi steradian. Right? So this is regarding solid angle. Right? Okay. Okay, I'll move on now. Right? Okay. Now, okay, after this, we'll go to some abbreviations for writing some bigger values and then smaller values. For example, you are asked to write 1 ton. You are asked to write 1 ton. How do you write it? Is 1000 kg. 1000 kg. Like this 1000, we can write it like, for example, 1 ton is what? 1000 kg. 1000 kg, that 1000 magnitude is too massive. Like sometime we have massive magnitudes of any mass, length, and time. At that time, we use some prefixes. Like, let me take some prefixes we use in physics for mentioning some bigger value in a easier manner. Right? Okay, we'll see one by one that. Okay, some abbreviation used for mentioning bigger values. Let me take abbreviation used for expressing different magnitudes. Let us see abbreviation. What are the abbreviation we use for expressing different magnitudes? Right? Say here. Okay, let me take here. First, suppose, let me take first here multiple, and here prefix. We use here symbol. See here, to mention some bigger magnitudes, we take help of prefixes here in physics. Okay, see here. Suppose we have 10 to the power, in case we have 1. We tell with the prefix it is, we can say this is, okay, this is hectare. Sorry, it is deca, it is. Okay. It is deca. See, 10 to the power 1, for that we write as prefix here, deca, and then it will be what? The symbol we use, dA. In the same way, for 10 to the power 2, we use hecto. For that, the symbol will be H. 10 to the power 3, for that we use kilo. The symbol we have K, right? For the 10 to the power 6, it is there. Then we use mega. For that, we use symbol capital M. So 10 to the power 9, we have giga. We use the symbol capital G. In the same way, 10 to the power 12, we can call this is tera. We use the symbol T likewise. So these are all multiples. This is a prefix and this is the symbol. These we use to represent that bigger magnitude values in a simpler manner. Right? We'll see to it now. So this is what multiples we say, multiples. In the same way, we have submultiples also. This is multiple, okay. Submultiples we have. Submultiples also we have. and their prefix here, and symbol for that. Even for symbol also we have for that. Okay. For submultiples we take 10 minus power of 10 will be minus, like 10 to the power minus 1 we represent with a deci symbol, prefix for that is deci, we use d for that. Like 10 to the power minus 2 is there, we use centi for that, centi, and the symbol will be c. Like 10 to the power minus 3, it will be milli, we use symbol m, right? In the same way 10 to the power minus 6, it will be micro, so symbol for that mu. In the same way 10 to the power minus 9, it will be nano. Okay, we use the symbol n. In the same way, like 10 to the power minus 12, we have pico, we use p here, right? Likewise, we have different multiples and submultiples to reduce our bigger quantity, like many zeros will come with a magnitude. To express that magnitude in a very simpler manner, we use here multiples and submultiples, right? Okay, these things we will take help later, right? Okay. Okay, now we move on, right? After having learned these abbreviations, we'll move on, right? Okay. Okay, now see here. Okay, in the SI system, we have learned all those things, like 7 fundamental quantities, 2 supplementary quantities. You have learned already. Now, if we look at the advantages of SI over all rest of the system of units, what are the advantages we have? Let me take the advantages of SI system, right? Okay, see here. Advantages of SI system. Advantages of SI system, right? What are the advantages? The first one advantages is SI system is a coherent system. Coherent. Its meaning is to cover up all the derived, 7 fundamental quantities we take to have all the derived quantities. To have all the derived quantities. Whichever derived quantity you take, we can write those derived quantity in terms of only 7 fundamental quantity. Right? Using 7 fundamental quantity, we can define all derived quantities in different branch of physics. Even any unit of any derived quantity, like derived quantity, you can say speed. Unit of that speed is meter per second. If I take speed, we have derived it from what? Meter per second, that is length by time. So speed has been derived from 7. In this 7, what length is there, time is there, like all 7 fundamental quantities are there here, right or not? Likewise, whichever quantity you take, we can derive different physical quantity from 7 only, right? So here 7 quantities unit, if you know, then you can get to know unit of any derived physical quantity, right? What is the meaning? I told you the SI system, it is a coherent system. What is here? I told you it is a coherent. What do you mean by coherent? Coherent system. What do you mean by coherent system? Coherent means having 7 as fundamental, we can fulfill the requirement of all the derived quantities. All the derived quantities we can express in terms of only 7 quantities, right? Okay, that's the reason it is called coherent, right? So electric current will serve the requirement of current, electricity, or electrodynamics. Electric current is a fundamental quantity which has been chosen from electrodynamics, like current, electricity, what electric related everything. You can write in terms of electric current. Like in thermal properties, like temperature is there. Whichever physical quantity in any different branches of physics, you take those different derived physical quantity, we can express or we can get their we can get their formula, we can define them in terms of only 7 physical quantities. That's the reason, like coherent means having 7 we can get all, having 7 we can get all. That's the reason this system is called. This is not the case for FPS, CGS, and then MKS, but here we have it. Having only 7 we can define all the rest of the physical quantities, right? Okay, this is a coherent system. And second one, second one, it is a rational system. It is a rational system. Second advantage of SI is it is a rational system. What do you mean by rational system? Here, rational it is in its process. It is rational. It is it given one unit for one physical quantity. One unit for one physical quantity. Like for example, you can have like different forms of energy you have. Suppose if I have like heat energy. Heat energy is also we have unit for that is joule. Heat energy. And even you can have like mechanical energy, mechanical energy, mechanical energy, mechanical energy also we have unit is same, it is joule, right? So like if you take CGS system, like for heat they have defined calorie as a unit, calorie as a unit. For mechanical they have defined joule as a unit. So like not joule in CGS system they have defined different erg like different units they have given. In CGS system for heat energy they are defined it as calorie, and even mechanical energy they are different energy, they are defined that energy unit as erg, right? So likewise different forms of energy in a CGS system they are given different unit, they are given different unit. But in case of SI, irrespective of different forms of energy, it may be heat energy, it may be mechanical energy, or it may be electrical energy, it may be any different forms of energy. The only one unit is defined for energy, that is joule. But if you take this CGS system, they are defined different units of energy for different forms of energy. For heat energy, they are given calorie as a unit. For mechanical energy, is erg as a unit in CGS, right? In likewise, in different cases, we find different units for energy in other systems. But in case of SI, we have only one unit irrespective of different forms of energy, that is joule. It is rational in its approach, irrespective of whatever forms of energy. The only one for one physical quantity, one unit. For one physical quantity, one unit. Right or not? Likewise. So second one is what? It is rational unit. It is a rational system. Right? Third one. Third one will be what? It is what? Metric system. It is a metric system. It is a metric system. What is metric system? You can write, for example, you have bigger values can be expressed in terms of power of 10, like practical, like for example, as I already told you, 1 ton. 1 ton is 1000 kg. 1 ton is what? 1000 kg. So here 1 ton is not a SI unit of mass. It's a other practical unit of mass. But this 1 ton I can replace, I can equivalent to SI as 10 to the power 3 kg. So 10 to the power 3 we have used here. So any other practical units, Any other, like ton is a practical unit of mass. It is not a SI unit of mass, but the ton we have written by using the 10 to the power, we have connected with SI. What is the SI unit of mass? Kg, right? For example, you have smaller unit, like for example, we have 1 gram. We have 1 gram. 1 gram you can write how? In terms of kg. Like again, power of 10, 10 to the power minus 2 kg. Like that. So using power of 10, like it may be multiple, like 10 to the power plus power or 10 to the power minus power, using like power of 10, you can write any, like from one unit to other unit, you can convert. Like one practical unit to SI or some SI to other practical unit. Right or not? So any practical, many plenty of practical units we have in the, like other than SI also we have many practical units. So connection between practical unit and SI you can make by using 10 to the power plus or 10 to the power minus. Right or not? So SI is a metric system. SI is a metric. It's because, so you can write that SI unit in terms of other practical units by using 10 to the power plus or 10 to the power minus. Like I mean multiples or submultiples. Likewise, we can say SI is a metric system. Using the power of 10, we can relate between other practical units to SI. Got my point? Likewise, you can go for relation. So in this way, we can say this SI is a metric system. Even a metric system is, this concept is very old. Even MK system is also a metric system. Even CJ system is also a metric system. There also this facility is possible. FPS system is not metric system. FPS, it is a British system. Okay, I told you it is a metric system. The next one, it is absolute system of units. It is absolute system of, it is absolute system of units. What do you mean by absolute system of units? Suppose if you go to the earlier days, in earlier days, actually weights are measured. Weight are force. Weight or force are measured using the value of G. Earlier, using values of G. G is what? Acceleration due to gravity. Let me tell you. Suppose what is the weight of 1 kg? Suppose we have 1 kg. What is the weight of that 1 kg? You will define weight of 1 kg is what? Mass into G. You will tell you it is 1 into weight is what? M into G. 1 into G is 9.8. You tell 9.8. Now you will define it like that. But earlier, the value of G is taken as a reference for defining the unit of force. Earlier, so they define the force, the weight of 1 kg is 1 kg force. What is the meaning of 1 kg force? Whatever may be the weight of 1 kg, that weight is called as 1 kg force. Right? 1 kg force. 1 kg force means weight of 1 kg. 1 kg force means what? Weight of 1 kg. 2 kg force means what? Weight of 2 kg. See here, 1 kg, weight of 1 kg means what? Weight of 1 kg means what? It is 9.8. G value is taken 9.8. M is 1. Weight of 1 kg will be what? 9.8 Newton. So 9.8 Newton is the defined 1 kg force. 1 kg force is 9.8 Newton. So in other practical units, G has been taken as reference for defining force. 1 kg, earlier days, 1 kg force means what? Weight of 1 kg is 1 kg force. Like now we say 1 Newton, no. Earlier they take help of G. They take a help of G, like 9.8 Newton, whatever you say, according to earlier in gravitational system of units, in gravitational system of units. It is other practical unit. Gravitational system of units, in that system, 9.8 Newton is called 1 kg F, 1 kg force. Now 9.8 we know it, but earlier they told a 1 kg weight. What is a 1 kg weight? 1 kg force. 2 kg weight equivalent force is 2 kg force. 2 kg equivalent weight is 2 kg force. 3 kg equivalent weight, 3 kg force. Like kgf is a unit of force. Kgf is a unit of force. 1 kgf equal to weight of 1 kg. 1 kgf equal to what? Weight of 1 kg. 2 kgf equal to what force? 2 kgf equal to what force? Weight of, like, weight of 2 kg. 3 kgf equal to weight of 3 kg, like that. So earlier, to define the weight or to define the force, they had taken gravity, acceleration due to gravity, as a reference. Right or not? Like acceleration due to gravity as a 1 kg weight is 1 kgf, 2 kg weight is 2 kgf. Such thing, this SI does not depend on something like G. It is independent. It has created its own. Like for defining 1 kg force, like 1 kg force means 1 kg weight. Here, nothing dependency of, while defining this SI units, it may be fundamental unit or derived unit. While defining a set of units, SI has created its own. It is independent of other quantities. Like K, while defining kgf, how do we depend on G? How do we depend on G? Likewise, in case of this, in case of SI, so while defining its own fundamental and derived units, it does not take help of other quantities. It has its absolute. It has created its own units. So while defining its own unit, it does not depend on other physical quantity. It has created its own unit. It does not depend on other physical phenomena. So it's an absolute system because it doesn't take help of G. Like how KGF, like gravitational system of units take help of G, gravitational system of units take help of G. Like here, in case of SI, it does not take help of like such a G value, something like that. It's a absolute. They made their own set of units. This does not depend on any other. Like in the same way, lastly, I have here, it is universally accepted. Universally accepted. This system is universally accepted. So this system, every country has accepted this system, and that made the things easy for any transaction, transportation of goods, whatever. So this is one more advantage, is that all the countries have accepted it. What are the advantages? It's a coherent system. It is a rational, because one physical quantity, one unit. It's coherent because all the derived quantities we can define using only 7 fundamental quantity. So it is a metric system. Like any bigger, like practical units, like bigger value of any unit, you can write in terms of power of 10. If you have bigger value of any physical quantity, you can write in terms of power of 10, and two small values, you can write it in terms of submultiples, like 10 to the power minus. Like it is a metric system. It is an absolute system because while defining its own set of units, it does not take help of any other systems. Any other systems. It has its own system. While defining its unit, it has not taken help of any other system. It's absolute. It has defined its own. Okay. So universal accepted. The last advantage of this is universally accepted. Right. So these are all advantages of SI over already existing systems. So now presently we use SI system. Done. Okay, we move on now. some guidelines we go for writing the units. Okay, we'll have some rules for writing the units. We'll have some rules for writing the unit. Let me take rules for writing unit. So what are the rules? Some rules has been defined. So all the units, symbol of all the units are mentioned with small letter. For example, meter, we take small letter. Second, we take yes, like we take we can say candela, we write small. Okay, we take but one thing is there, if any unit comes after the name of scientist, that will be taken capital. For example, Kelvin, we have to write capital. Why Kelvin we have to write capital? Newton we have to write capital. Newton we have to write capital. Joule we have to write capital. Any unit which is named after a scientist, then the symbol of that unit should be taken capital, symbol of that unit. If not, all the units should be taken small. Only where if any unit comes after the name of scientist, that unit should be taken capital. Then other than that, like meter is small, right or not? Like you can take a meter per second is a small, right? Like uh, gram is small. Like kg is what? K is a subscript, we take k. K is a there is a sorry, it's a prefix, it's a multiple. It is what is k is 10 to the power 3, it's a multiple. So likewise, whatever unit you have, okay, if suppose ampere is there, ampere symbol we have to write capital, because what, this ampere is named, this symbol of that SI unit of electric current, that is ampere, is named after the scientist, so we have to write capital. So what I mean, unit should be written, the symbol of unit should be written small. In case suppose that symbol comes after the scientist name, then that should be taken capital, right or not? Only where if that symbol comes from the name of scientist, that has to be taken capital. If not, all the things you have to take small letter, right? So okay, what is I mean here, symbol of units are written in small letter. Symbol of units are written in small letter. Okay, if suppose symbol is on the name of scientist, if symbol is like symbol of unit, you can say, is named after a scientist, named after a scientist, then it is written with capital. Then it is written with, it is written with capital, written with capital letter. Okay, it is written as small. If symbol of unit is named after sorry, this is named after a scientist, after a scientist, then it is written, then it is written, okay, with capital letter, capital letter, right? Okay, okay, only when the scientist name on which the unit symbol of unit made, then you have to use capital. Otherwise, all units should be written small, right? Okay. No, we should not use plurals per unit. For example, uh, symbol of symbol of length is what is a unit of length? It is a meter. You cannot use meters like that. It's wrong. Symbol of unit should not be used in plurals. Kgs, it's wrong. Kgs, it's wrong. Symbol of unit should not be used in plurals. Second one is symbol of units should not be used in plurals, right? Like you cannot go with kgs, meters. You cannot write it like that. Meters, kgs, like amperes. It's wrong. All these are wrong. So unit should be single. Ampere, like meter, like kg, like Kelvin, Kelvins. No, plurals. You cannot use symbols of unit should not be used in plurals. And even after writing the symbol of unit, you should not keep full stop. That is also one thing. After writing the symbol of unit, don't put full stop. After writing, after the symbol of unit, after the symbol of unit, don't use full stop. Don't use full stop. Okay, these three are some guidelines for writing the units. Any unit, a symbol of any unit which is named after a scientist, like unit of temperature is Kelvin, there you can use capital K. But meter, it is not derived from any scientist name, small. Right or not? Like that, ampere is named after scientist, capital A, like that. Symbol of units are written in small letter usually. If symbol of unit is named after scientist, then it is written with capital letter. Right? Okay. So symbol of unit should not be used in plurals. After the symbol of unit, don't use full stop. Right? These are all some guidelines are there for writing how to write unit. Right? Okay. In the next class, we'll go with the measurement of length, measurement of time, we start the measurement of length in the next class. Right? Okay. Today we'll complete it. Thank you.